Dear students, in this video I would like to discuss superposition principle. So we are discussing the series of topics which are related to the interference chapter. So this superposition principle is very much important so that we can explain the phenomenon of interference, diffraction, polarization, etc. So let us start this. Superposition principle. So here already I have written the principle. First we read out and then I will explain it. When two or more waves, two or more waves cross at a point, two or more waves cross at a point, the displacement at that point is equal to the sum of the displacements of the individual waves. So this is the superposition principle statement. So what they are trying to say, okay, two or more waves. So for example, I am going to consider wave 1. Two waves I am drawing. The first wave, this is wave 1, right? And then I am going to consider another wave. Okay, so this is wave 2. Okay, so two or more waves cross at a point. So this is the point where these two waves are going to cross. This is the point. Cross in the sense both are going to superpose one over the other. Okay, at this point these two waves are going to cross. So in this point what will happen? Listen, this is the amplitude. Okay, this is the displacement of the wave. Okay, the same thing here also. So this is the displacement. So this is the displacement of individual wave. For example, I am giving only the example. The amplitude is 1 centimeter here and this amplitude is 0.5 centimeter. Okay, only for example I have given 1 centimeter and then 0.5 centimeter. This is the point where both are going to superimpose with each other. Okay, see here at this point both are going to meet together, cross at this point. So in this case, so these two will be added together at this point. Listen, the cross at a point, the displacement at that point is equal to the sum of the displacements of the individual waves. So what we can say here, we will get the displacement like this. Okay, this displacement will be like this, 1 plus 0.5 centimeter, so that it will be 1.5 centimeter, 1.5 centimeter, where at the point where it meets together or cross together or superpose together, at that point the displacement will be changed. The displacement will be equal to the sum of the displacement of individual waves. Okay, so that is what superposition principle. Now you see, when two or more waves cross at a point, the displacement at that point is equal to the sum of the displacement of the individual waves. Okay, so this is what you have to understand, or otherwise we can say the principle of superposition may be applied to waves whenever, okay, two or more waves traveling through the same medium at the same time. Okay, so when two waves are coming at one point, definitely superposition will take place. Okay, so due to that superposition, its displacement will be changed at the particular position or particular point where we are considering. So that we have to understand. Okay, so after that, after crossing that, this is the point it is meeting, right? So after this position, both will cross, both will pass through each other without being disturbed. Okay, so the red color wave, after that it will cross like that only, and the green color wave, that is the second wave, after it will go like this only. Okay, only at this position where it is crossed together, okay, in that place only the displacement is changed. After that both will pass through each other without being disturbed. That means we can say the at the point of intersection, its displacement will be changed. After that they both will separate out again, both are unaffected. Okay, after that there won't be any change in the waves. Okay, only at the point of intersection, okay, it will have the difference. After that, beyond that point of intersection, both will separate out again and they will be unaffected. So this is what we have to understand, right? So the individual wave displacement, for example, here I mentioned, right, it may be positive or negative. Okay, it may be positive or negative. So one, not only the positive value, it may be positive or negative also. Negative in the sense we can consider. Okay, so this is the negative displacement. So the individual wave displacements may be positive or negative, but the point where it is going to intersect will be the summation, sum of the displacements of the individual waves. Okay, if it is the negative value, for example, the first wave is having 1 centimeter amplitude and the second wave is having minus 0.5 centimeter. What about the summation of these two? It will be 0.5 centimeter. Okay, it will be the sum. Either the individual wave displacements may be positive or negative. Okay, so already I said the superposition is giving the important idea that can explain phenomena of interference, diffraction, etc. So this is very important phenomena. And the next one is it works for any type of waves. If you consider sound wave or water wave, that is water surface wave. Okay, surface wave water surface wave and electromagnetic wave. So this superposition principle can be applied for any type of waves, but it works only under certain conditions. Under these certain conditions. So first we have to see what are the certain conditions to get the superposition principle. So I hope you understand what is the definition, that means a statement for the superposition principle. Next we are going to see the conditions of the superposition principle, at what criteria the superposition takes place. Now we will discuss conditions for superposition of waves, when the superposition will takes place. Okay, there are three conditions we are going to discuss. Let us see one by one. The first condition should be the waves which are going to be superposed are of same type. Okay, or of same type. So already I have given some examples: sound wave, water surface wave, or electromagnetic wave. Okay, for example, if you are considering electromagnetic wave. Okay, already I said for the superposition minimum two waves are required, or more also we can consider, but minimum is two. So the two waves, if you are considering, these two waves should be are of same type of wave. If you consider electromagnetic wave, it should be electromagnetic. If you are considering sound wave, both should be belongs to the sound waves. So in that way we have to maintain. So the first condition for superposition of waves is the waves which are going to be superposed should be of same type. Okay, and the next one, in the medium only it will take them, that means the waves will propagate inside the medium. That medium should be linear, so we can call it as linear medium. What is the meaning for linear medium? Inside the medium, that means throughout the medium, the frequency and the velocity of the wave should not be changed. The medium will not change the frequency as well as velocity of the wave, any wave which is passing through the medium. That medium is called linear medium. Okay, so that is also important for the superposition of waves. Okay, so the what is meant by linear medium? Linear medium is the medium in which the frequency and the velocity of the wave never changes, right? And the next one is very important, that is the if the two waves we are considering, that should be coherent in nature. Both should be coherent in nature. What is the meaning of coherence? Coherence is in the sense that two waves should have the same frequency. Should have the same frequency. What is meant by frequency? Number of cycles per second. So by seeing this two, you can understand both are having the same frequency, right? And then both should have the constant phase difference. Both should have constant phase difference. Phase difference. Okay, so these are the three conditions to be followed for the superposition of waves. What is the first one? The waves which are going to superpose should be of the same type. the medium in which the wave is going to propagate. That medium should be linear medium in which the frequency and the velocity of the wave never changes. And the next one is it should be coherent. That means the two waves should maintain the same frequency as well as the constant phase difference. Okay, these are the conditions to get the superposition of waves. I hope you understood this definition, that is a statement of the superposition principle as well as conditions to get. Okay, so please go through that. If you have any doubt regarding this, you can ask me in the comment box. Thank you everyone.